All right, data trailblazers, buckle up for a fresh dive into our Explainable AI series. Today, we're zooming into automatic piecewise linear regression, APLR for short, on the MPG dataset from Seaborn. I'm running this in Google Colab, breaking it into neat code blocks so you can ride shotgun. The MPG dataset is all about miles per gallon for cars from the 70s and 80s, and we'll use APLR, a clever twist on linear regression, to predict it, then unpack everything with interprets local and global explanations. APLR bends the rules of straight lines, and we're about to see how it fuels our insights. Let's rev up and roll. To kick things off, we need our toolkit in place. In Colab, I start with pip3 install interpret to grab the interpret library, our XAI powerhouse. Then, I'll load a hefty lineup. NumPy and Pandas for data crunching, Seaborn to snag the MPG dataset, and Sklern's train test split, mean squared error, and our 2score for splitting and scoring. From interpret, I bring an APLR regressor from the Glassbox module, our hero today, and set up inline visuals with set visualize provider and inline provider. Now, the MPG dataset. I load it with Seaborn's load dataset MPG and drop any nulls with dropna. The head gives us a peak. MPG 18, cylinders 8, displacement 307, horsepower 130, weight 3504, acceleration 12, model year 70, plus origin and name. It's a vintage car lover's dream. Let's linger on this MPG dataset. It's got character. We're talking 398 rows after nulls are gone, with MPG as our target. Miles per gallon, the fuel efficiency holy grail. Features? Cylinders 4, 6, 8, engine size tiers. Displacement cubic inches of engine volume. Horsepower, raw power under the hood. Weight, pounds of steel. Acceleration, seconds to hit 60 miles per hour. And model year, 70 to 82, a timeline of tech. Origin and name, like USA and Chevrolet Chevelle Malibu, add flavor, but we'll focus on the numeric 6 cylinders to model year. This data is a snapshot of American, European, and Japanese cars from an era of gas guzzlers and efficiency experiments. I set X as those 6 features and Y as MPG, ready to split. Before we model, let's prep the data right. I could have checked for missing values with isna.sum, but dropna already cleaned house. 398 rows means we lost a few, likely from horsepower or weight gaps. No categorical columns like origin need encoding here. We're all numeric, all gas-powered. I use train test split with 20% for testing, random state 42 for consistency, 80% trains, 20% tests. Why these features? Cylinders and displacement tie to engine size, horsepower and weight to power and mass, acceleration to PEP, and model year to tech evolution. It's a car nerd's playground, and we're predicting how far a gallon takes you. Now let's talk APLR. APLR, automatic piecewise linear regression, isn't your grandpa's linear regression. Regular linear regression draws one straight line, say, weight versus MPG, a single slope. But APLR, it's smarter. It breaks that line into pieces, fitting multiple segments to catch twists in the data. Imagine weight. Light cars might gain MPG fast, but past 3,000 pounds, it flattens out. APLR spots that bend. I fire up APLR regressor from interpret, pass X-train columns as feature names, and fit it on X-train and Y-train. Predictions on X-test yield a mean squared error of 5.7274. Root that, about 2.39 MPG off, and an R-square of 0.8878 to 88.78% of MPG variance nailed. That's a tight fit, but let's see what's under the hood. Here comes XAI, local explanations. I run APLR.explainLocal on the first 5 test samples. For the first, it predicts 27.0246 MPG. Spot on near the true 26.0. Contributions. Weight's a whopping 9.1979. Huge lift. Horsepower adds 2.2445. Displacement 0.3288. And APLR's magic shines with interactions. Displacement and horsepower 0.5648. Weight and acceleration 0.3945. Displacement model year 0.2531. Negatives? Model year at negative 0.3419. Acceleration of model year to negative 0.4215. Horsepower model year negative 0.1821. Pulling MPG down. The graph you're seeing? A bar chart with a colossal orange bar for weight stretching right, dominating. Orange nudges from horsepower and displacement, blue bars for model year combos jutting left. Weight steering this MPG call. Let's shift gears to global insights with APLR.explain global. Feature importance across all data. Weight reigns at 3.4129. Massive. Horsepower in model year is 1.1114. Weight in model year 1.1389. Horsepower solo 1.0745. Model year 0.6029. All positive movers. Displacement in model year 0.4218 and displacement in horsepower 0.4194. Flex muscle 2. Cylinders hits 0.3076. Acceleration a meek 0.022. But its combo with model year is 0.2127. The graph on screen? Horizontal bars. Orange giants for weight, horsepower model year, and weight and model year extend right. MPG heavyweights, joined by orange for displacement and cylinders. Few blues here. APLR balances negatives locally. Weight's global crown is undisputed. Time to dissect this output. It's a gold mine. The head showed MPG 18, cylinders 8, weight 3504, model year 70. Think big, old American iron. MSE 5.7274 means errors around 2.39 MPG. Solid when MPG spans 10 to 46. Our superscript 2 at 0.8878, that's 88.78% explained. APLR's piecewise bands are working overtime. Locally, that 27.0246 prediction, off by just one, leans on weights 9.1979. Imagine a 3,000-pound car. It's a fuel factor. Horsepower's 2.244, 5 adds punch, but model year's negative 0.3419 says older cars gulp more. Globally, weights 3.4129 and horsepower model year's 1.1114 screen consistency. Big, powerful, old cars tank MPG, but APLR catches how newer models, even 70s new, shift that. Car makers could drool over this. Why is this XAI output a big deal? Locally, weight's 9.1979 dwarfed all. APLR saying this car's mass drove its MPG, tempered by model year's negative pull. Those interactions, like displacement and horsepower at 0.5648, show APLR smarts, bending where straight lines fail. Globally, weight's 3.4129 aligns with physics. More pounds, more gas, while horsepower model year's 1.1114 tracks tech's MPG boost over time. Compare this to basic regression. APLR's piecewise fits and XAI visuals give us a richer tale. In Colab, these orange and blue bars pop with show. Weight's orange Titan is a showstopper. It's not just numbers, it's car design decoded. Let's park this journey. We snagged the MPG dataset, a 70s to 80s car time capsule, crafted an APLR model that bends with the data, hit 88.78% our superscript 2, and used interpret to lift the hood. Local explanations crown weight king for one MPG guess. Global ones mapped weight and horsepower model year as fuel efficiency titans. APLR's piecewise flair, paired with XAI, turns car specs into a roadmap. How cylinders, weight, and years shape MPG. Grab this code, tweak those features, and take it for a spin. This XAI Trex got me hooked. Hope it's sparking your curiosity too. See you next lap for more data thrills.